Solve one problem for the calculation of mass of dry flue gas per kilogram of fuel burned. Second question. Solve one problem for the calculation of the percentage composition of the dry flue gases by volume.
Let us first understand how to calculate the mass of dry flue gas during the combustion of 1 kilogram of fuel. Here we have to define what is the amount of flue gas that is getting generated because of the combustion of 1 kilogram of fuel. Now if we observe the combustion process, then during the combustion there is no loss of the carbon. So we have to compare what is the mass of carbon in fuel with the mass of carbon in flue gas. So how we can write the formula? So mass of flue gas per kilogram of fuel is equal to mass of carbon in 1 kilogram of fuel divided by mass of carbon in 1 kilogram of flue gas. Now there is the problem to solve. Then here the mass of carbon in fuel that is given, that is during the composition of fuel there is the carbon that is available in the fuel and it is given in the question. So this is, we can write this numerator from the given data, that is the mass of carbon in 1 kilogram of fuel. Now main question is that how to calculate the mass of carbon in 1 kilogram of flue gases. Now this flue gas is getting generated after the combustion process. So what is happening during the combustion? When carbon present in this fuel combines with oxygen, then there is the carbon dioxide is getting formed. And in the same way carbon monoxide is also getting formed. So we have to find out what is the amount of this carbon dioxide as well as carbon monoxide that is getting generated during the combustion of carbon that is present in the fuel. So how to find out that? So we have to write here the mass of carbon in flue gas. So in flue gas carbon present in the form of carbon dioxide as well as carbon monoxide. Now we will write the equation. So here carbon C plus oxygen gives us CO2. In the same way carbon plus oxygen gives us carbon monoxide. So first we will solve this. C plus O2 gives us CO2. Now what is the molecular mass for this carbon? That is 12. Then oxygen. So here there are 2 atoms of oxygen. So 16 multiplied by 2, that is 32. And here carbon plus oxygen, that is 12 plus 32, that is 44. Now I will divide here on both sides by 12 because we have to find out what is the amount of carbon dioxide that is getting formed during the combustion of 1 kilogram of carbon. So carbon amount is 12. So if I divide both sides by 12, then 1 kilogram plus 8 by 3 kilogram will give us 11 by 3 kilogram. Then how we can read this? That is for the combustion of 1 kilogram of carbon, 8 by 3 kilogram of oxygen is required and it will produce 11 by 3 kilogram of carbon dioxide. So I will write here. Now we have to compare this carbon and CO2. So 1 kilogram of carbon will give us 11 by 3 kilogram of CO2. Now 1 kilogram of CO2 will contain what is the amount of carbon, because we have to find out what is the total mass of carbon in flue gases. So in 1 kilogram of CO2, here is the question mark. So now we will make here the cross multiplication, that is 1 multiplied by 1 is equal to 11 by 3 multiplied by x. So what is the amount of this x? That is 3 by 11. So I will write here 3 by 11 kgc. So this is the answer. So in CO2 there is 3 by 1 kilogram of carbon dioxide, there is 3 by 11 kilogram of carbon. So I will write here that is 3 by 11 kilogram of carbon that is present in 1 kilogram of CO2. Now in the same way we will write here the equation for carbon monoxide. So C plus O2 will give us CO. Now here O2 is 2 times, so I have to write here 2, and to balance this C we have to also write here as a coefficient 2 for this carbon. Now we will take the molecular mass. So carbon is having 12 multiplied by 2 plus oxygen 16 multiplied by 2, that is 32, and here carbon plus oxygen. So one atom of carbon and one atom of oxygen, that is 12 plus 16, that is 28. So 2 multiplied by 28. So 24 plus 32 will give us 56. Now I will divide on both sides by 24. So 1 kilogram plus 4 by 3 kilogram will give us 7 by 3 kilogram. So how we will write this? For the combustion of 1 kilogram of carbon, 4 by 3 kilogram of oxygen is required, and it will produce 7 by 3 kilogram of carbon monoxide. Now we will compare this carbon and carbon monoxide. So 1 kilogram of carbon will give us 7 by 3 kilogram of carbon monoxide. Now in 1 kilogram of carbon monoxide, what is the amount of carbon? So here is question mark. So again we will make here the cross multiplication. 1 multiplied by 1 is equal to x multiplied by 7 by 3. So what is the value of x? That is 3 by 7 kilogram of C. So 1 kilogram of carbon monoxide will contain 3 by 7 kilogram of C. So again we will add this amount of carbon, that is 3 by 7 kilogram. So this is the total amount of carbon in the flue gas, because when the carbon burns, then in the flue gas carbon dioxide as well as carbon monoxide is present. So we will write this 3 by 11 kilogram of C in CO2 and 3 by 11 kilogram of carbon in CO2 plus 3 by 7 kilogram of carbon in CO. So here we have to write this in the denominator. Now we will solve one problem to find out the mass of dry flue gas per kilogram of fuel burn. I will read what is the given question. The ultimate analysis of dry coal burnt in a boiler is carbon 84%, hydrogen 9% and incombustibles 7% by mass. Determine the mass of dry flue gases per kilogram of coal burnt if the volumetric composition of the flue gas is carbon dioxide 8.75%, carbon monoxide 2.25%, oxygen 8% and nitrogen 81%. So this was the given question. Let us first understand the given data. Now here the fuel composition is given by mass. So for the dry coal, carbon is 84%. So it is given by mass. So 84 by 100, that is equal to 0.84 kilogram. Then hydrogen is 9%. So we can say that 9 by 100, 0.09 kilogram. Incombustible 7%, so we will say that which is equal to 0.07 kilogram. Now volumetric composition of flue gas is also given. So if we observe, this is the volumetric composition. So carbon dioxide 8.75%, so 8.75 divided by 100, that is equal to 0.0875. Now what is the unit? Because of volumetric composition we have to give unit here, that's a meter cube. Then carbon monoxide 2.25%, so 0.0225 meter cube. Then oxygen is 8%, 0.08 meter cube, and nitrogen is 81%, 0.81 meter cube. Now if we observe, we have to find out what is the mass of constituents in kilogram per kilogram of flue gases, because we have to first find out what is the amount of carbon that is present in the flue gas. So this amount of carbon we have to take in kilogram. So this volumetric analysis given the amount in volume, that is CO2 0.0875 meter cube, then CO 0.0225 meter cube. So we have to convert this into kilogram. So for that we will make one table. So first column is constituents. So what are the constituents in the flue gas? That is CO2 is there. So I will write here first constituent as a CO2. Then CO, then O2 and last one is N2. So these are the constituents. Now second column we have to write the volume of 1 meter cube of flue gas. So this volume that we have to convert this percentage in the volume. So we have to write this. So we will give here the letter A. That is the volume of 1 meter cube of flue gas, that is 0.0875. 0875. Next is 0.0225. Then next is 0.08 and next is 0.81. Now molecular mass. So molecular mass that we have to calculate. So CO2, that means one atom of carbon, that is 12 plus 32. So here 44. CO, that is carbon plus oxygen, that is 16. So 12 plus 16. 28. Then oxygen is 32 and N2, that is 28. So these are the molecular mass that we have to write. Then the proportional mass. So suppose for molecular mass we will say B, then proportional mass C is equal to A multiplied by B. So we have to multiply this and we have to write here. Then when we calculate here, we have to take the summation of C, that we have to take all the addition for this proportional mass for the all the values. Now how to calculate the mass of constituent in kilogram per kilogram of flue gases? Suppose we will say D, then D is equal to C divided by summation of C. Now the calculated value of proportional mass is 3.85, 0.63, 2.56 and 22.68. So when we add all these, we will get summation of C 29.72. Now how to calculate the mass of constituent in kilogram per kilogram of flue gases? That means in 1 kilogram of flue gas, what is the amount of CO2? So we have to take C divided by summation of C, that is 3.85 divided by 29.72, that is 0.130. Now in the same way, carbon monoxide is 0.021, O2 0.086 and N2 0.763. Now we will find out what is the mass of carbon in 1 kilogram of flue gas. So we have already seen the formula. So what is the formula? That is this carbon present in flue gas in the form of carbon dioxide and carbon monoxide. So we have to take 3 by 11 CO2 plus 3 by 7 CO. Now what is the amount of CO2 present in the flue gas? So CO2 present is 0.130. That is in kilogram. So 3 by 11 into 0.130 kilogram plus 3 by 7 multiplied by amount of CO. So amount of CO is 0.021. So multiplied by 0.021. So when we solve this, we will get 0.044 kilogram. So this is the amount of carbon present in 1 kilogram of flue gas. So this is the formula, that is 3 by 11 CO2 plus 3 by 7 CO. This is the formula to calculate this. Now we will move for the final question, that is the mass of dry flue gas per kilogram of coal burnt. So for the combustion of 1 kilogram of this coal, or we can say dry coal, what is the amount of or mass of the flue gas that is getting generated? So we have to write the formula. Mass of carbon in 1 kilogram of coal. So mass of carbon in 1 kilogram of coal, it is given carbon 84%, that is 0.84 kilogram. So we have to write this value in kilogram divided by mass of carbon in 1 kilogram of flue gas. So mass of carbon, it is given 0.044. So when we calculate this, we will get 19.1 kilogram. Now we will move for the second question. I will read what is the given problem. A blast furnace gas has the following volumetric composition: CO2 11%, CO 27%, H2 2% and N2 60%. Find the theoretical volume of air required for the complete combustion of 1 meter cube of gas. Find the percentage composition of dry flue gases by volume. Assume that the air contains 21% of O2, that is oxygen, and 79% of nitrogen by volume. So this was the given question. Let us first understand what is the given data. It is given that the blast furnace gas, that is the fuel, is the gaseous fuel, and carbon dioxide is 11%. So 11 by 100, that is equal to 0.11 meter cube is the volume for this carbon dioxide. Carbon monoxide is 27%, that is 27 by 100, 0.27 meter cube. H2, hydrogen is 2%, that is 0.02 meter cube, and nitrogen is 60%, that is 0.60 meter cube. So this is the volume for each constituent in the gaseous fuel. Now we have to find out what is the theoretical or minimum volume of air required for the complete combustion of the gaseous fuel. So how to calculate this amount of air? So that we have formula. So we will write this formula: 100 by 11 in the bracket 0.5 CO plus 0.5 H2 plus 2 CH4 plus 3 C2H4 bracket complete minus O2 meter cube. Now why there is minus O2? So in gaseous fuel, whether there is some oxygen present in the gaseous fuel, then we have to subtract this oxygen, and that's why here is minus O2. Now we will write this formula, that is equal to 100 by 21 in the bracket. Now 0.5 multiplied by CO. So CO is given 0.27. So we will write 0.27 plus 0.5 H2. So 0.5 multiplied by H2, 0.02 plus CH4. So this methane is not present in gaseous fuel, plus C2H4. So this is also not present, so we will write 0 minus O2. So oxygen is also not present, so we will write here minus 0 meter cube. So when we solve this, we will get the answer 0.69 meter cube. So this is the answer of first question. Now we have to find out the percentage composition of dry flue gas. So for that, we will first understand how this combustion process is taking place. Now this is the gaseous fuel, that is the blast furnace gas, and in this it contains carbon dioxide 11%, carbon monoxide 27%, hydrogen 2% and nitrogen 60%. So when the combustion process is taking place, then this carbon monoxide combines with oxygen and the carbon dioxide, that is CO2, is getting formed. Then here is the hydrogen. So hydrogen, when combines with oxygen, it will form H2O or water. But the main important point is that we have to find out the percentage composition of dry flue gas. So here for this dry flue gas, we will not consider this H2O, that is H2 combines with oxygen and it will form H2O, but we will not consider this because we have to find out the dry flue gas. Then nitrogen. So nitrogen is present in the fuel, that is the blast furnace gas, it is 60%, and it is also given that the theoretical air that is getting supplied for the combustion process, and it also contains some nitrogen. So it contains nitrogen, that is 79%, and that is mentioned in the question. So we have to take the from air, it is 79% of N2 is provided. Now 79% of N2 multiplied by the theoretical air that we have already calculated in the first question, that we have to take here. Now we will move for the calculation of the total volume of carbon dioxide. So for that, we have to first consider the combustion process of this carbon monoxide and it is getting converted into carbon dioxide. So we will write here the combustion equation. So here CO, that is carbon monoxide, combines with oxygen. CO plus O2 gives us CO2. Now we will balance here. So here O2 plus O, that is 3 atoms of oxygen are there, and here is only 2. So I will write here the coefficient 2. So here total number of oxygen 2 multiplied by 2, that is 4. So here is 2. So here also we have to write 2. So if we balance the left hand side and right hand side, 2 atoms of carbon on the left hand side, 2 atoms of carbon on the right hand side, then here 2 oxygen plus O2, that is 4 number of oxygen, and here also 4 number of oxygen. So this is getting balanced. Now we will write this in terms of volume. So how to write this by volume? Now if we observe here, 2 volume of carbon monoxide, that is 2 meter cube of CO plus 1 meter cube of O2. Now we have to consider here coefficient will give us 2 meter cube of CO2. Now we will divide this by 2. So we can say that 1 meter cube of carbon monoxide when combines with half meter cube of oxygen, then it will give us the 1 meter cube of carbon dioxide. That means when the 1 meter cube of carbon monoxide burns, then it will produce 1 meter cube, that is same amount of volume carbon dioxide. So here this CO, that is 0.27 meter cube carbon monoxide burns. Then after combustion it will generate same amount of carbon dioxide, that is 0.27 meter cube. So after combustion, what is the amount of carbon dioxide? So we will write here, after combustion CO will convert in CO2, and in dry flue gas CO2, which is equal to 0.27 meter cube. And in this gaseous fuel CO2 is already present, and which is equal to 0.11 meter cube. So CO2 already present in fuel, 0.11 meter cube. So what is the total volume of CO2? That is this 0.27 plus 0.11. So which is equal to 0.38 meter cube. So this is the total volume. So we will make underline for this. This is the total volume of CO2. Now we will move for the next. So H2 we will not consider here. So this is getting completed, that is CO2 as well as CO. So this CO is getting converted into CO2. Now the remaining is N2. So N2, that is nitrogen present, already present is 0.60 meter cube, and from the theoretical air it is 79%. So what is the amount of theoretical air that we have to supply for the combustion? So theoretical air required for combustion we have calculated 0.69 meter cube. Now out of this 0.69 meter cube of theoretical air, 79% is nitrogen by volume. So it is mentioned in the question. So we will calculate what is the volume of nitrogen in the air. So 79%, that is 79 by 100 multiplied by 0.69, that is 0.545 meter cube. So this is the volume of N2 that is available in the air. Now what is the volume of N2 already present, that is 0.60 meter cube. So N2 already present in fuel, that is equal to 0.60 meter cube. So what is the total volume of N2? So we have to add these two, that is 0.6 plus 0.545, which is equal to 1.145 meter cube. Now we will find out what is the total volume of dry flue gas, that is the volume of CO2 plus volume of N2. Nitrogen and carbon dioxide volume that we have to add. So it is 0.38 plus 1.145, which is equal to 1.525. So this is the total volume of dry flue gas. Now we have to find out the percentage composition. So this dry flue gas is nothing but the addition of this carbon dioxide and nitrogen. So what is the percentage of carbon dioxide present in dry flue gas? So out of this 1.525 meter cube, CO2 is 0.38. So we have to convert this into percentage. So we will take the ratio 0.38 by 1.525 multiplied by 100, which is equal to 24.92%. That means carbon dioxide present in flue gas is 24.92%. In the same way, what is the amount of nitrogen, percentage of nitrogen in dry flue gas? That is 1.145 divided by 1.525 multiplied by 100, that is 75.08%. So we can say that approximately 25% carbon dioxide present in flue gas and approximately 75% nitrogen is present in the flue gas.